My name is Steve Seymour. I am a specialist solutions architect for networking. I work across Europe, Middle East, and Africa, and I'm based in London. So thank you very much for having me back here in Tel Aviv again. The purpose of this session is to take you through some of the fundamentals of creating your VPC, your virtual private cloud within AWS. If you already have VPC, if you're already used to configuring things like route tables, internet gateways, virtual gateways, that kind of thing, you're probably in the wrong session. This is about the basics. We're starting from the beginning, and as part of this session, we're going to build a very basic internet-connected VPC. We're also then going to explore a few other topics related to VPC, so peering, remote connectivity over VPN and Direct Connect, and a few other features that we've announced in the last 6 months or so. So, where do we start? Well, first of all, you've probably got an EC2 instance, or you're familiar with EC2. This is Elastic Compute Cloud. It's the unit of compute that we have, a virtual machine. You might have a single one, or as the name E, the elastic in EC2 implies, you might have many EC2 instances. And you might be scaling up, you might be scaling down, and this is great. This is EC2 running inside AWS. But the thing is, running inside AWS, you need to be able to get to these EC2 instances, which means you're going to need some sort of network. So, whether you're familiar with networking already and you're familiar with concepts such as firewalling, routing, etc. within your data center, or whether perhaps you're from a more development-based background where you haven't had to think too much about networking in the past, the objective of this session is to show you that actually within AWS, the concepts of networking are actually pretty simple. So for both the experienced and the inexperienced with networking, you should all be able to configure your VPC quite easily by the end of this session. So, VPC, what is it? It's virtual private cloud. So this is the virtual networking environment we have inside AWS for connecting your EC2 resources together and to things like the internet or your private network. Within your VPC, you get to decide things like the IP address ranges that we're using. And if you want to, the individual IP addresses that we assign to the EC2 instances. Within that VPC, you also get to define things like subnets. So we're going to talk about this in a bit more detail later on in the session. But you get to configure routing. So we want to be able to connect our VPC out to the internet. So as you can see here on the right-hand side, we've got a router, which is that route table icon down in the bottom corner, connected to the internet. This is the environment that we're going to be building as part of this session. Okay, so what should you expect? By the end of it, you should be very familiar with basic VPC concepts. You will have seen the walkthrough of a complete VPC setup, a very basic one, connecting your VPC to the internet, exposing your EC2 instances so that they can serve traffic. But by the end of this session, you will have seen a complete walkthrough of that process. And also, we'll be looking at ways that you can tailor that environment to meet your specific needs. So perhaps controlling that access, using things like security groups and network ACLs to manage which traffic can come and go from your VPC. That's the goal for this first part of this session. So let's jump straight in. Let's look at building this internet-connected VPC. It's very basic, it's very simple, but it's probably the thing that most of you need to achieve with your networking environment inside AWS. These are the components and the steps we're going to be walking through. And the first one is actually really, really important. You have to choose an IP address range that we're going to use for the VPC. Once you've done that, we're then going to configure our subnets. And these align to availability zones. So we'll touch on that in more detail along the way. We're then going to look at how do we connect our VPC out to the internet, because without connection to the internet or your on-premises network, it's a pretty lonely VPC. Can't talk to anyone, no one can talk to it. So let's get it connected to the internet, and then we're going to look at how we authorize the traffic. So they're the steps involved in connecting your VPC. Start with that important topic at the very beginning, choosing an address range. Okay, CIDR notation, classless interdomain routing. This is a way of representing an IP address range that we're going to use throughout this presentation. If you're not familiar with it, this is what it means. So if you take an IP address and you break it out in binary, this is what it would look like. So 172.31.0.0 looks like that in binary. The /16 on the end, well, what that specifies is we're going to take the high 16 bits of the 32 bits that make up this address, and we're going to fix them. Everything else we can change. What that means in English is that 172.31 is fixed, and we can use any values between 0 and 255 for the zeros on the end there. So that's how we're going to be representing IP address ranges throughout this session, and it's how we use them within VPC and within subnets in AWS. So let's choose our IP address range. For this session, I've picked 172.31.00/16. Why have I picked /16? Well, first of all, it's a nice large amount of address space. /16 is around 65,000 IP addresses, probably enough to get by for now. If you have a choice, then please go for something as large as a /16. It gives you the option to be flexible later on. And also, choosing the CIDR block of IPs for your VPC is one of the few things that you can't actually change once you've created the VPC. You can, of course, delete the VPC and create a new one, define a new range, that's absolutely fine. But it's one of the things that you can't change once you've created the VPC and you've started using it. Why have we chosen 172.31? Well, 172.31 is part of a range of addresses that are listed in RFC 1918. They're known as private IP addresses. So you might have seen 192.168, 10. And 172.31 is part of one of the other ranges in RFC 1918. Now, you can pick absolutely any IP address range you like. This is a virtual private cloud. So within VPC, you can use any IP addressing, whatever you want to use. You could even use some public IP addressing if you liked. We wouldn't route it out on the internet, but within your VPC, it'll work absolutely fine. But where possible, use RFC 1918 addresses. And this is because when you're working with other people, either in your organization or elsewhere, RFC 1918 makes it very clear that this is a private network. As I say, the /16 gives you over 64,000 addresses, so hopefully enough to get by. And one really, really important thing, if you have some existing networking in place within your environment, please make sure you don't overlap your VPC with your existing network. You may have no plans at this point to connect the two together, but why make life hard for yourself in the future if potentially you do? So try and avoid overlapping IP address ranges. This includes in other VPCs and with your on-premises network. So just make sure that each time you create a VPC, you pick a unique block of IP addresses within the environment with which you plan to work. So now that we've defined our VPCs, we need to start thinking about subnetting or creating subnets inside our VPC. Now, everything you're going to be seeing throughout this session is demonstrating what we see within the AWS console. Now, obviously, everything that we do within the console, you can actually do via command line, via the APIs. But just in terms of making the slides look a little bit more interesting, we've used the console for the screenshots. But you get the idea that you can do this via one of our many ways of interacting with our APIs. So here's our VPC. We've got our 172.31/16 address range. Now, within AWS, we're going to be working in the EU West 1 region here in Ireland. You're probably familiar with the term availability zone. Now, the thing about an availability zone, you can think of it, if you like, as a data center. It doesn't exactly match one-to-one. An availability zone can actually be many data centers within AWS. But the point about an availability zone is that it has a different risk profile. So if there happened to be something that impacted one availability zone, then hopefully it won't impact another one. And when you architect your applications, you should be spreading them across multiple availability zones. So let's put the availability zones, or AZs, onto our diagram. We've got 3 AZs here in the EU West 1 region, A, B, and C. And when we create our subnets, they are aligned to a particular availability zone. So you can see here 3 individual subnets. They don't span availability zones. They're within a single one. And to keep things simple, I've put a single subnet in each availability zone. You can, of course, create as many as you like, up to the amount of addresses you have available. Now, I've picked some addressings for these subnets. So within 172.31, we're then going to have .0.0/24, .1.0/24, and .2.0/24. So why have I picked /24? Well, again, this is a good pattern if you don't have any other particular specific requirements. A /24 of address space gives you plenty of IPs within that individual subnet. And if you need more, you can quite easily create another subnet of another /24 within each of those availability zones. One other thing that we're going to do on these subnets is we're going to enable something which is called auto-assign public IP. Now, what this means is whenever we create an EC2 instance in this subnet, by default, we're going to give it both a private IP inside your VPC, but we're also going to give it a public IP. So now, in theory, it could be reached over the internet if we configure a bunch of other things that we're going to look at. Now, the thing about this parameter is it makes things easy in terms of launching EC2 instances and making them reachable, and you can always override this option on an individual subnet basis or on an individual EC2 instance basis. But we're going to set the default now to automatically assign a public IP address. Now, just going back to the /24 of IP addresses that we've allocated, that's going to give us 251 available IP addresses. Now, those of you that are good at maths, you'll realize that's not the same as 256, which is what we should be able to assign from a /24. The reason is that we actually reserve some of the IP addresses. So we reserve the lower 4 IP addresses, so the network address, and then the first 3, and we also reserve the upper address as well, so the 255. So they're addresses that you can't use, but you can launch your EC2 instances to use any of the other IP addresses within that subnet. So, a couple of basic concepts just to recap on that. We're going to use a /16, that gives you your 64,000 or so IP addresses. We're going to have our /24 with our 251 usable IP addresses, and we're going to assign 1 subnet per availability zone. This is a very, very simple VPC. And of course, you might want to do something different. So we're going to look at the concepts later on of perhaps public and private subnets, where you might want more than 1 subnet in a particular availability zone. We're going to look at changing the routing within the environment. These are all good reasons why you might want to do something different. And the /16, to go back to that point, you might already have an internal IP addressing schema that says we can't allocate a whole /16 every time we create a VPC. We need to allocate something smaller. But what I say is start from a basic set of concepts, document them, and then establish that as your standard. You can then always adjust it later on if you need to. But these are good starting points if you don't have something already in place. Okay, so we now have our VPC. We've got our subnets created within it. We could launch some EC2 instances. But as I said earlier, it's going to be a pretty lonely place because without anything else, we can't talk to this VPC. We can't communicate with the EC2 instances, and they can't communicate with anything else either. It's a closed-off private network. Remember, you're in control of this virtual private cloud. So we need to create a route out to the internet. Now, this is where things get interesting in our VPC. Everything interesting in a VPC relates to a route table. So we're going to see a few of these. Now, a route table is basically a list of rules that says, I have a packet, I'm trying to send it somewhere, how do I get to that place? It's a very simple concept. And when we create the VPC, we also create what's called a main route table or a default route table. However, one of the very powerful things about VPC is you don't have to just use that default route table that we give you. You can create as many route tables as you need to associate with your individual subnets. So now each subnet can have its own routing table if you want to. For the purposes of this, we're going to stick with our main routing table. So this is what it looks like. You see the route table listed there at the top. And down at the bottom here, we have an entry that says 172.31.00/16, our VPC. And it says the target, so where am I going to send traffic for those addresses, is local. What that means is everything inside my VPC can talk to each other. And you can't remove that entry. That's our main route table, nothing else in it, which is why we can't actually talk to the internet, because we don't have a route in there that says, I'm trying to send traffic to something on the internet, how do I get there? That's why at the moment this is a closed-off environment. So now we need to create what's called an internet gateway. Now, the thing about an internet gateway is it's not a router, an individual single router, a single point of failure. It's actually a highly available service that we provide, but we represent it to you as a single object within your account, an internet gateway. You're going to attach that internet gateway to your VPC. So you can see here we have IGW and an identifier, and on the right-hand side we can see it's attached to our VPC. And the thing about this internet gateway is we want to be able to send traffic here that is destined for the internet. So how do we do that? Well, we go back to our route tables. Remember, this is the place that interesting things happen in our VPC. We've got our local entry there still at the top, but we've now added another entry. And we've put 0000/0. And what that means is all available IP addresses. It's the default route. So we're now saying if traffic is destined for something that is not our local VPC, please send that traffic to the internet gateway. Hooray, now our VPC can talk to the internet and people can talk to us. Okay, now that things are connected and we can talk to the internet, we actually need to think about what do we want to allow to happen. It's all very well having this channel of communication, but we probably want to make sure that it's secure, that we're controlling that traffic. We have two things that we can give you to help do this. Now, in a traditional networking environment, you might be looking at a firewall of some sort with a very detailed rule base. Well, we have an equivalent inside AWS in the form of network ACLs and security groups. Now, first of all, we're going to start with network ACLs. It's a simpler concept. Now, the thing about a network ACL is it is stateless. Now, what a stateless firewall does is it means that we have to take traffic coming into our EC2 instances, coming through our network ACL, and we have to define a rule that allows that. But then the reply to that traffic also needs to be allowed, because we aren't tracking the state. You might have heard of connection tracking. We don't do that within a network ACL. We need to define the traffic both inbound and outbound. You can take that network ACL and you can apply it to an individual subnet. So now we're not actually talking about the individual EC2 instances. We're saying traffic is either allowed or denied coming into the subnet. So we can use this as a very simple tool to block or allow traffic at quite a high level before it gets anywhere near our EC2 instances. Just to zoom in a little bit, these are the two rules that are currently in this network ACL. And actually, what you can probably see there, that top entry says rule 100 comes above the default deny, the default drop at the bottom. What does it actually do? Well, basically it says allow everything. So in my very simple VPC, what I've decided to do is allow all traffic through the network ACL. Now let's look at the other control that we give you to manage security. We have security groups. So here's a bunch of EC2 instances. We haven't got the individual subnets or anything shown on this diagram. We have a bunch of front-end, let's say web servers. The orange security groups are used around them. And we have some back-end instances here, perhaps some sort of application or a database or something like that. And the thing about security groups is they usually follow the structure of your actual application. And what do I mean by that? Well, what we're going to do is define a security group that's called my web servers. And we're going to apply that security group to all of those instances at the top, because they're going to share a common rule base. They're going to allow a certain type of traffic to all of those web servers. Typically it's going to be port 80 or similar. Our back-end servers here, our database or our application, again, we can actually group those together. We know that they're going to be accepting a certain type of traffic from a certain place. So let's create a security group and apply it to all of those as well. For that web server security group, as I said, we're going to use them as web servers as an example. What we want to do is actually allow all traffic from anywhere on port 80. They're web servers. They've got to be able to be visible to the world. But for those back-end servers, we actually don't want anyone to be able to talk to them directly. So the security group that we configure for these back-end servers needs to be configured to allow traffic from the web servers only. So you can draw a diagram like this to simplify what your security groups need to do. And once you've worked out that we have two very logical groupings here of web servers versus back-end servers, we can configure the security groups. So what we've got here is a security group called My Web Servers, and quite predictably, it allows HTTP on port 80 from anywhere. The source is 0000/0 again. That's now allowing that traffic from the internet through the internet gateway. It's passing through the network ACL on the subnet, and now getting through to our web servers on port 80. But we're not allowing anything else, because security groups are denied by default. So we've allowed port 80, everything else is blocked. So we have no one trying to log in via SSH or anything else to our web servers. The traffic will never get to your operating system running on those EC2 instances. If we now look at the back-end servers, this is where security groups get really quite powerful. If you took the previous example, we could say allow connections in from a certain set of IP addresses, and those IP addresses could be our web servers, and we can allow those into those back-end database servers on port 2345. But now we have to manage this security group. We have to think what IP addresses have our web servers got, etc. Well, actually, there's a much simpler way with security groups. You can actually refer to another security group as the source of this traffic. So what this rule is actually saying is that we're going to accept connections on TCP port 2345 from our web server. So that SG identifier on the end of the source, if you look above it, that's the security group identifier for the web servers. So now we don't need to manage the individual IP addresses for our back-end servers' security groups. Really powerful function of security groups. So a couple of other things. We've talked there about allowing traffic in. Now, to go back to network ACLs, I said that these were stateless, so we have to define traffic in both directions. Well, with security groups, we don't have to. Security groups are stateful, so when you actually create a rule in a security group and it allows traffic into your EC2 instance, we automatically allow the reply. Within that security group, we can control egress as well. We saw examples for inbound traffic, but we can control whether these EC2 instances are allowed to reach out to do things. So do they actually even need to talk to the internet? If not, let's block that. Wherever you can, use security groups as references for the source in other security groups. So exactly in the example that we just had, for the backend servers, refer to the web servers by their security group identifier. This means you don't have the overhead of managing the individual IP addresses or entries inside that security group. And then finally, you may have heard of IAM, Identity and Access Management. Well, a lot of customers will establish a one-to-one relationship between the idea of a security group and an IAM role. And you can see that a security group controls what traffic is allowed to reach me, say as a web server, whereas an IAM role is used to control what it is that I can actually do. And you can see that there might be a natural relationship between the two of those. We haven't got time here to cover the detail of IAM roles, but effectively it's a set of permissions that establishes what it is that EC2 instance is allowed to do. Okay, so we've now got our very basic internet-connected VPC with a couple of subnets in there. We've got our EC2 instances, network ACLs, and security groups. All of you can easily follow that set of steps, and you will have an internet-connected VPC. And an interesting point is that you probably already have one of these. If you created your AWS account anytime after 2013, we actually create a VPC for you. Within your account, you'll see that you have a VPC in the 172 range. It already has an internet gateway. It already has the routing that we've talked about here. It's already configured for you. So this is VPC by default that we have inside your account since 2013. But equally, I think it's a good exercise for people to go through and configure a VPC themselves and go through the steps we just looked at. As you can see, it really is quite simple. So we want to connect to our VPC from somewhere else. Now, once again, we need to look at routing because, again, that's where interesting things happen inside our VPC. It's how we control where traffic flows. But what might we want to connect to? Well, we might want to connect to other VPCs. They might be our VPCs, or they might be someone else's VPCs. Perhaps a partner that we work with, or perhaps just a VPC in another account within your organization. You might separate out different teams, different departments. You all have your own accounts. Perhaps you all have your own VPCs, but you want them all to connect to each other. Equally, you might want to connect back to your corporate network. So we want to connect back perhaps over an IPsec VPN or over Direct Connect. And I'm going to look at those in a bit more detail. Okay. Now, first of all, let's go back to those route tables. We put a very simple entry in our main route table which said we're going to reach out to the internet. We're going to default route all traffic to the internet. But what if we have some subnets that we want to be internal? So here's our environment again. We've got perhaps our front-end web servers again, our back-end database servers or application servers. But this time, let's put them in two different subnets. And in terms of how our networking behaves here, we obviously need those two subnets to talk to each other. Well, that's fine. Our route table has our local route entry in it. We want our web servers to be able to talk to the internet. Fine, we have our route that we created earlier, a default route out via the internet gateway. But actually, our subnet with our application servers in it, we don't need to talk to the internet. So what if we create a route table for that subnet that has no route to the internet? Now what that means is you can demonstrate that these EC2 instances are not reachable at all from the internet. No matter what you've done with the security groups, however you've configured the software, there is no route in that route table that allows them to talk to the internet. But it doesn't prevent your web servers talking to them. So this is a fairly common setup. We actually use the terms in our documentation public and private subnet. So the top subnet here you'd consider a public subnet because it has that route to the internet, whereas the bottom subnet you would consider as a private subnet. But what about those EC2 instances in our back-end databases? Perhaps they need to go and get updates, Windows updates, or reach out to a Yum repo or something like that. How are they actually going to do that if they don't have a route to the internet? Also, perhaps we've turned off that option that gave them all a public IP address as well. So all they've got is a private IP address and no route to the internet. What do we do? Well, this is where the NAT gateway comes in. Here's our setup. We have our private subnet on the left. We have our internet-connected subnet on the right. So I've just shifted that diagram we had in the previous slide around. What we're now going to do is create a NAT gateway. Now again, this is like the internet gateway. It's managed by AWS. It's highly available. It's not something you need to think about in terms of configuring it, but it's there to give you the ability to route traffic from a private subnet out to the internet. So when you launch a NAT gateway, you're going to have to choose a public subnet to put it in, because obviously the NAT gateway needs to be able to reach to the internet. But we then need to send traffic to it. And how are we going to do that? Well, we're going to create a default route inside our private subnet now that says send all traffic going to the internet, so 0000 again. We're going to send that to the NAT gateway. That NAT gateway, because it's in a public subnet, it has a public IP address. It's actually an elastic IP address, so a fixed IP address that we assign to the NAT gateway. And now that's how we're going to get out to the internet from our private subnet. But we still don't have any public IP addresses in that private subnet, and you still can't reach into it from the internet. So now we have the ability to reach out, get our updates, but no one can actually reach into that private subnet. Nice, simple concept. This is what the route table entry would look like on that private subnet. Remember, we've created a brand new route table specifically for this subnet. It's still got the local entry in it, but its default route has the identifier of the NAT gateway rather than the internet gateway. Okay, let's speed up through these last couple of bits here. Let's look at connecting to other VPCs using VPC peering. So, what is VPC peering? Well, as I said, you could have multiple VPCs that want to talk to each other, but a very, very common architecture we see for VPC peering is a shared services VPC. The idea that you might have a VPC that's running things like your logging, your monitoring, perhaps some remote admin tools, that kind of thing. You don't want to have to deploy that into every single account, into every single VPC that you create. So you could create a single VPC with those services in it. We then want to connect that VPC to all of your other ones. Now, as long as we followed the original rules that I said at the beginning of not overlapping our IP address space, this actually becomes really simple. We take our two VPCs here. We've got both of them in RFC 1918 address space. We've got a 172.31 and we've got a 10.55. These are our two VPCs. We want to connect the two together so that traffic can be exchanged between them. Peering is the tool for doing that, and the process for setting it up is quite simple. You have to configure the connection, and I'll go through the steps involved in a minute, and accept them. But one thing before we do that, we talked about security groups earlier, the ability to reference security groups as a source in another security group. You can do that across VPC peering as well. That's something we added in the last couple of months. So actually, we can manage our security groups very easily, again, without specifying individual IP addresses. So let's set up the peering connection between the two. The first step is we have to initiate the request. So the VPC on the left is going to create a request to the VPC on the right. If it's in the same account, it's a nice simple drop down. You just choose the identifier for that VPC, and we're good to go. If it's in another account, you have to know the account number, and you have to know the VPC identifier. It doesn't appear in a drop down. You have to type that in. Once you initiate that request, the other VPC has to accept it. This is what the initial request looks like. You can see the choices here, choosing the source VPC and the destination VPC. But once that's in place, we now have to do the accept. So this is a handshake that has to happen between the two VPCs. This is what it looks like. It will show as pending in the console. You have to select that peering connection and then click accept. Once that's done, great. We have two VPCs that are allowed to talk to each other. But let's go back to that principle that only interesting things happen in the VPC when you have routes. So now that we have the agreement in place, now let's put an entry in our route table. So here we are, we have our route tables at the bottom. We need to create an entry that says, to get to 10.55 from my 172.31, I need to create an entry that says the target is the peering connection. Now you can see on here it's the third one down. It says the target is PCX dash and an identifier. That's a peering connection. And we need to do that on both sides of the VPC peering to be able to route traffic in both directions. Those of you that are paying attention will have also realized that there's an additional entry in this route table at the bottom, and we're going to touch on that next, an entry via the virtual gateway. Okay, so now we want to connect back to an existing, perhaps on-prem network, a corporate network of some sort. So we're going to talk about IPsec VPNs and Direct Connect. Now, there's a whole bunch of content out there about this. You can look on YouTube for some of the deep dive sessions around both of these topics. So I'm just going to keep it fairly high level just so that you're familiar with the concepts. On our left, we have our corporate network. On our right, we have our VPC. These are the two things that we want to connect to each other. we're going to use an IPsec VPN. So this is an encrypted tunnel that we run over the internet between the two of them. But the first thing we have to do to configure our VPN is define the customer end of this service. Now, both for VPN and Direct Connect, the term that's generally used is the customer gateway. So here we are, back in our data center, we're going to create our customer gateway. Now, this actually isn't something that we deploy, but we need something in the console to refer to your end of the VPN connection. You're our customer, it's a gateway, it's a customer gateway. Pretty simple. On the AWS end, we need a gateway as well to link these two endpoints together. So we're going to have a VPN between them. This is called the virtual gateway. So you're going to see it referred to in the console as VGW. Now we have two endpoints for our VPN. When you create a VPN via the console, what we actually do is create two IPsec tunnels. This gives you a highly available, resilient solution. And on the AWS end, the two endpoints for these VPN tunnels are actually in different availability zones. So we're actually using our own architectures here, the ones that we recommend to you, to provide a highly available VPN solution. And both of those connect to that customer gateway on your end of the connection. If you wanted to make your end of this VPN highly available, you could simply have a second customer gateway and another pair of IPsec tunnels to us. Now we have 4 tunnels, 2 gateways on each end. Once again, though, this is great until we have a route, though we can't use it. So we need to go back into our route tables, and as you saw on the previous slides, we need to create an entry that says, to get to my corporate network, the 192.168 network, send all traffic via the virtual gateway. So here we are back at our route table. We've got an entry in there at the moment that says, to get to the local VPC, that entry is still there, but we've added the route via the virtual gateway now. You can see that this is quite a simple concept, and following it through from all of the other entries, it's as simple as saying, I have traffic that's going to these IP addresses, where do I send it next? And in this case, obviously that's to the virtual gateway. Direct Connect is slightly different. Direct Connect is a physical connection between your network and AWS. So we have Direct Connect locations all around the world that are associated with our regions. We have equipment in those locations, routers, and you can then order a connection between your network, a physical piece of fiber, between one of our routers and your equipment. The thing about Direct Connect and VPN is that actually they both provide the same functionality. They're providing you with secure connectivity between your network and your VPC. One of them is an encrypted tunnel over the internet, and one of them is a private piece of fiber between your equipment and ours. Direct Connect is dedicated to you. And the thing about Direct Connect is it actually gives you a lower price for data transfer. So if you have a lot of data that is going to be leaving AWS, then Direct Connect gives you a lower per gig data transfer fee. Also, it's a lot more bandwidth. So Direct Connect, the units that we deliver in are 1 gig and 10 gig. There are options to get smaller amounts of bandwidth via some of our partners. But overall, if you're using Direct Connect, our recommendation would be that you also use a VPN. So this way you have high availability. You have a physical connection, perhaps multiple Direct Connects, but you also have a VPN for failover. Okay, let's move on to DNS in our VPC. We've talked a lot about the network level functionality, but what about name resolution? Now, DNS inside a VPC is actually very, very flexible. You can do things like configure your own DNS servers if you really want to. But I'm going to focus on the feature that we provide you if you choose to use our DNS solution. So you have the DNS options within your VPC, and you'll notice that there are 2 very specific ones. One that says DNS resolution and one that says DNS host names. Most customers have both of these turned on. You don't have to, but most customers do. What do they actually give you? Well, DNS resolution means that we provide you with a DNS server inside your VPC, so you don't have to run your own. It's highly available, it's part of the VPC environment. DNS host names mean that every time you launch an EC2 instance, we assign it some host names, and that's where things get quite interesting. This is the standard page for an EC2 instance inside your VPC. And you might notice on there we have a couple of things related to DNS. We have a private DNS entry, and you can see embedded in that name is basically the IP address of the instance. So in this case, IP-172.31.compute.internal. So within our VPC, we can use that to resolve that individual EC2 instance. Great. Nothing particularly special about it. But if we look at our public IP address, this is a little bit special. So in this case, we turned on that option that said, assign me a public IP address. Again, we've got a DNS entry that looks like it's related to that public IP address in some way. but it resolves slightly differently. So let's step outside of our VPC. We're sitting now just on a normal Windows machine, we've resolved this name, and as you'd expect, it resolves to the public IP address because I'm outside the VPC. What happens if I'm inside the VPC though? So now we're sitting inside our VPC, I'm resolving that same public DNS entry. But if you look at the reply, what actually came back was the 172.31 address. So the thing about this DNS name is that it actually gives you the right answer wherever you're located. So if you're outside, it gives you the public IP address. If you're inside your VPC, it gives you the private IP address. So a pretty cool piece of functionality there. We also have something called Route 53 private hosted zones, and this is your way of controlling any DNS zone that you like within your VPC. It doesn't affect anyone else. You choose which VPCs it's visible in, and you can use it to override any other DNS entry that is out on the internet. So if you want to create a zone, we're going to use one demo hosted zone in a moment. Doesn't matter whether someone owns it or not. Within your VPC, you now control every entry for that particular zone. To do this, we have to step into the Route 53 console. It's not within the VPC console. You can see we create our hosted zone here, and we choose which VPCs it's going to be available to. Once that's done, we can then create an entry in this hosted zone. And you don't have to know anything about DNS here. It's as simple as put in the name that you want to create, put in the IP address. Once we've done that, we can then go back to our EC2 instance, and we can try and resolve that particular name. So in this case, example.demohostedzone.org. And you can see that the response we got back was 172.31.099. It's whatever we defined within Route 53. So we're now in control of that particular domain name. Doesn't matter if someone else has it registered out on the internet, we now control it as far as our VPC is concerned. This gives you some interesting options for some internal DNS domains or controlling traffic that is attempting to go to certain public domains as well. Okay, let's squeeze a couple more bits in on the end here. Let's talk about VPC Flow Logs. So within this environment, we might want to monitor our traffic. We want to know what's actually happening, what's being allowed and what's being denied by our security group rules. VPC Flow Logs is something that gives you that. You can turn it on for individual network interfaces, you can turn it on for the whole VPC. But what it does is create an entry in a log for you to be able to see that traffic as it comes in, where it was destined to, whether it was allowed or denied. And you can see whether it was blocked or allowed by a security group or a network ACL. This is great for logging, and there's various tools out there for then presenting this visually. You can build something yourself if you like, but it's also really helpful for troubleshooting networking. I've also used it to do analytics against security groups and say, have we actually configured this security group correctly? If we're seeing lots of traffic hitting it on a port I haven't defined, is that someone trying to attack me, or is that something that I've missed in the configuration? It's really useful for being able to do that. And then finally, let's touch on just VPC endpoints for S3. Let's say we have a VPC that is connected back to our corporate network. We don't actually want to connect it to the internet in this case, so it's pretty private. But we do want to reach out to S3. Now, S3 is a service that's available via public endpoints. It's available on the internet. But we want to reach it from inside our VPC. Well, how do we do that? Well, we can create a VPC endpoint for S3 that allows us to get traffic from within our VPC just out to S3. It doesn't go out to the internet. So we create a VPC endpoint, but beyond that, we can also apply some policies to it. So we now get to say this VPC endpoint allows us to reach out to this very specific S3 bucket. We can also then configure the other end of that. We can configure the bucket to allow traffic in, but only from that VPC endpoint. So now we have the ability to control both ends of that connection. Okay, I think we've probably covered enough there. We should be hopefully on time. If you've got any feedback about this session, please scan the QR code or use the app to submit some feedback. We take your feedback very seriously, and we use it to shape our events in the future. So thank you very much for coming to the session. I'm going to be in the Ask an Architect booth from now on.